Hello everyone. In this video, I'm going to discuss about the Terraform Cloud. Terraform Cloud implementation options. We have successfully implemented Terraform CLI for infrastructure management and explored its integration with Azure DevOps for DevOps workflow. In addition to these two options, we also have the alternative of using Terraform Cloud and HashiCorp Cloud Platform. The implementation of this solution offers two primary workflows. So, initially, we discuss about the Terraform CLI options, okay, where we were running the Terraform commands from our terminal. The second option which we discuss about the CI/CD implementation. Okay, we implemented CI/CD in Azure DevOps. As I do have mentioned, apart from these two options, we do have one more options which is called as Terraform Cloud, or I would say HashiCorp Cloud Platform. Initially, it is used to be called as Terraform Cloud. Right now, HashiCorp is saying it as HashiCorp Cloud Platform. So, for implementation of these Terraform Cloud or HashiCorp Cloud Platform, we do have two options. First is called version control workflow, and second is called CLI-driven workflow. Leveraging version control system for automated infrastructure provisioning and collaboration. If you see in this diagram, the Terraform VCS driven workflow, left hand side is developer who's going to update the code where in my GitHub. Okay, and once he's going to update the code in GitHub, then our Terraform cloud is going to task for it. It can be our creation of the resource or deletion of the resource. But the source code will be present inside my GitHub account. Okay. The second option is CLI driven workflow, utilizing the Terraform CLI for manual and automated infrastructure management directly from the command line. So in this case, what we are going to do, our code will not be present inside the GitHub. Rather than the GitHub, it would be present in my local desktop. And from local desktop, I'm going to run the Terraform commands, and then the changes will be implemented in Terraform Cloud. So in the upcoming videos, we are going to focus on Terraform VCS driven workflow. Then once this is done, then we will move on the implementation of Terraform CLI driven workflow. Key features of Terraform Cloud. Going forward, I'm not going to mention HashiCorp Cloud Platform. Okay, I'm going to mention Terraform Cloud only. Fully managed SaaS solution. No need to manage infrastructure or worry about scaling. So what is the exact meaning of it? So it is a software as a service. So in this case, we did not need to do any kind of hardware management in terms of installing our Terraform or managing it. It would be done by Terraform Cloud only. State management, remote state storage with automatic backups and versioning. As we do have discussed in our remote state management, we are responsible for managing our state file. So we discussed we do have n number of option in Azure Cloud, AWS Cloud, or I would say Google Cloud to store our state file. But in Terraform Cloud, it would be managed by them only. VCS integration. Integrate with GitHub, GitLab, Bitbucket, and other to trigger run on code changes. In the last slide, we took an example of GitHub. So our source code was present in GitHub. Whenever we are doing any changes in our source code, automatically it triggers Terraform part. But apart from GitHub, we are having n number of options: GitLab, Bitbucket, or I would say Azure Repo 2. And then whenever we are going to do changes in our code configuration, automatically it is going to trigger the things. Workspaces. Organize your infrastructure code by environment or project with isolated state and variables. So Terraform Cloud, we do have hierarchy like this: organization. Then within an organization, we are going to have the project, and within a project, we are going to have the workspace. And this workspace is nothing a dedicated folder to run our code. We are going to have very detailed discussion regarding this one in our upcoming video. Plan and apply automation. Automatically run Terraform plan and Terraform apply based on code changes or manual approval. So we do not need to run Terraform plan or Terraform apply in VCS part. We only need to select the option if you want to run Terraform plan or Terraform apply. And we do have one more thing, like automatically it will run if there would be any kind of changes in the source code. Policy as code. Enforce compliance and governance policies using Sentinel. So what is the exact meaning of it? I would say I'm creating a virtual machine. My all my users to have a restriction, they can only create a virtual machine of this specific size D version only. Okay. To implement this one, we are good to use the Sentinel policy. If we are going to create a virtual machine from different size, I would say E series, then we are going to get the error. Or I would say if you are creating any resource in Azure, the tag should be present. If tag is not present in your code, automatically you're going to get the error. To achieve this one, we are good to use Sentinel. Secure secrets management. Integration with HashiCorp Vault and other secret management tools to securely store sensitive data. So it supports n number of secret management where we are good to store our sensitive data. Free and paid plans. A free tier with limited features with paid plans offering advanced features like team management, enhanced security and policy enforcement. So basically we are having n number of plans for our Terraform cloud. Okay, so in the next slide we will discuss about it. If you see the Terraform pricing options, one it is free, the other one is a standard, then plus, then enterprise. So it depends upon the kind of workload and requirement the organization choose between the standard plus and enterprise. We are going to use the free version. In free version, we are good to upgrade it to a standard one to do some of our labs. So we'll do it. You're good to explore this site for a detailed description. Okay. Terraform VCS implementation steps. So basically the first step which we have to do, we have to sign up on Terraform Cloud. Once you sign up, we need to create an organization. I would say we are working in Wipro. So we'll create an organization on a name of called Wipro. Okay. Then create a new project and workspace. In Wipro, I would say there would be n number of teams. One team, it would be for security. Another team, it would be for Python development. Then for Java development. So for each of them, what we are going to do in the Wipro organization, we are going to create a different project. Okay. One project for my security team, one for Python development, one for Java development. And within this project, we are good to create n number of workspace. Means one for dev environment, one for QA environment, one for prod. The same thing for my Python development, one for dev, one for QA, and one for prod. So this thing can be achieved using workspace concept. Okay. Once my workspace is created, what we need to mention, we need to connect to VCS. VCS means version control system. So where we have pushed our Terraform code. As I do have mentioned in the last slide, it can be your Azure repos, Bitbucket or GitHub. Once it is done, eventually what we have to do, whatever the Terraform is going to do the operation in cloud only. Okay. So in this case, we need to integrate our Azure cloud with our Terraform cloud. For this part, we need to create an authentication part. And once it is done, we are good to run the Terraform apply in our code. In our upcoming videos, I'm going to do a demo on each and every step. So with this, we have completed this Terraform intro video. Hello everyone. In this video, we are going to create an organization. But before creating an organization, we need to have Terraform Cloud account. So I'm going to click on create your free account. Then I need to mention my username. I will mention here Akash Kumar, some random number, and will update my email ID, password for it. Then I'll click on terms of use and privacy policy. Then create account. See, it has sent mail to my email ID. I need to confirm. I have already logged in my email ID. So see, this is the mail which I have received. I'm going to click on this verification link. So our email ID has been verified. So for the first thing which we have to do to create an organization, I'll click on create organization. I'll mention the organization name as Wipro and some random number to make it unique. And then I'm going to click on create organization. So it create a default project to start our work, but will but we will create a dedicated project for our implementation. I'll mention this project as VCS workflow hyphen demo hyphen project. I'll click on create. So our project has been created, and inside the project we need to create a workspace. It has three workflow: version control workflow, CLI driven workflow, and API driven workflow. So in this video we are going to discuss about the version control workflow. I'm going to click on my version control workflow. It is asking me to connect to version control provider. So I'm going to click on GitHub and then github.com. I've already logged in on my GitHub account. That's why it has not asked for any verification. But for you, maybe it will ask. So you need to mention your username and password. So it is showing my repo name. Then I'm going to click. So the workspace name I want VCS workflow hyphen workspace. I'm going to click on advanced option. It is asking for Terraform working directory. The directory that Terraform will execute within this default to the root of your repository and is typically set to subdirectory matching the environment when multiple environment exist within the same directory. So what is the exact meaning of it? If you see what we have mentioned our repo. But inside this repo, we are going to have n number of subfolder. So it is asking which dedicated folder you want to mention at work directory. If I'm going to mention this working directory, so whatever the Terraform file it is present inside this folder will be executed. So in my example, what I have done, I do have dedicated folder name called as day-10. In this one, I'm having main.tf. So this is the module Linux VM, the module which is present inside my ak-edu organization, and we are passing the values day-10. So it is going to execute all the Terraform commands inside this day-10 only. So it is going to create my virtual machine and the other configuration. So it is asking for other option auto apply. Set this workspace to automatically apply changes for successful run. If disabled, run require operator approvals. We are good to ignore this one. I want a branch based rather than a tag, and then I'm going to click on create. What we have done till now, we have signed up to Terraform Cloud. Then we have created an organization, and within the organization, we have created a project. And inside the project, we have created a workspace. And then the workspace is connected to my GitHub. And inside this GitHub, we do have dedicated folder of day 10 in which our Terraform configurations files are present. So in the next video, what we are going to do, eventually, all the resources are going to be created inside my Azure account. So I need to do the authentication between the Terraform Cloud and Azure. So we are going to create the service principal for it and will provide the required access. Everyone, in this video, we are going to do the authentication part. So what is the requirement of authentication? If you see this Terraform Cloud, and this Terraform Cloud need to connect with my Azure to create the resources. So to create the resources, we need to do the authentication part. And for the authentication, we are going to use a service principal. So the command to create a service principal is this one. It will create a service principal and then it will assign a contributor access at subscription level. And we need to update 4 environment variables in our workspace. We already have the tenant ID and the subscription ID. We only need to update the client ID and client secret. So let me run this command. So this is my account. I'm going to click on Cloud Shell. Then I'm going to paste the command. I will click on enter. So service principal has been created and it has the contributor access at subscription level. I will copy this value and I'll paste it here. See, the first thing which I need is it my ARM client ID, which is my app ID, and it is asking for the client secret, which is my password. As we do have discussed, I need to update all these four values in environment variable. So I'm going to click on add variables. Then we are having a two option, Terraform variable and environment variable. These variables are available in the Terraform runtime environment. Let me click on environment variable. And I will copy the first value, which is my ARM client ID. Will mention here key, and the value is this one. We'll paste here. Then the second value is ARM client secret. I'm going to copy it. And then I will click on add variable. Then I will select environment variable. Then update the key. And then I'll copy the value. I'll paste here. This is sensitive. So I'll click on sensitive option. We have updated this ARM client secret as sensitive. So if I'm going to click here and then I'm going to click on edit variable, I won't be able to see the value. I would be only able to update it. While in the case of normal variable, if I'm going to click on edit variable, I'm going to see the value also. So the third one is tenant ID. And the value is this one. I will click on add variable. And finally, my subscription ID, and then update the value. I'll click on add variable. So in this video, what we have done, we have created a connection between my Terraform Cloud and the my Azure account. In the next video, I'm going to do a demo regarding the implementation steps. So thanks a lot for watching the video. Hello everyone, in this video I'm going to do a demo on VCS implementation. So what we have done till now, we have created an organization. Once the organization was created, we have created a dedicated project, and inside this project we have created workspace, and this workspace is connected to my GitHub account where my source code is present. And then we have connected this workspace to a dedicated Azure subscription. To Azure subscription. So what would be the next implementation? The next implementation, it would be to run the Terraform lifecycle command from our dedicated workspace. As we do have discussed from our local machine, what we are doing the same thing like running the Terraform init, Terraform plan, and Terraform apply or Terraform destroy. And our state file was present either locally or inside our remote state management. But when we are going to run our VCS workflow, our state file will be stored inside our dedicated workspace. So let's start our demo. So this is the workspace I have created, name called VCS workflow hyphen demo hyphen project. In this workflow, I'm going to click on plus new run, and then the run type, it would be plan and apply. Firstly, the planning phase will be implemented, then the apply. We'll click on start. The plan is in queue stage. It is waiting for change summary. See, the plan has been started, and the Terraform version which is using Terraform 1.10.2. See, these resources are going to be created. One, it is my virtual network. The second one is my subnet. The third one is my resource group. Fourth one is public IP. Fifth one is my NIC. And sixth one is my virtual machine. It is asking, please review the plan output. I'm, I'm going to click on the review the plan output. It will show me again about all the 6 resources which are going to be created. If there would be any kind of change, it would have showed here one change or two change or one or two destroy. Currently, we are only creating the 6 resources. That's why it is showing 6. I'll click on confirm and apply. Then I will say looks good. Then again I will click on confirm plan. Apply is started. It is waiting for resources. See, all the 6 resources are going to be created. So the first thing, it would be resource group. The status is creating. See, our virtual machine has been also created. Let me quickly check inside my portal. I'll click on resource group and the demo-rg has been created. And inside this one, we are having all the 5 resources. If you see here, it is showing state version created. So our state file has been created and it is present here. Let me click over it. So our state file is present here. And if you want to download the state file, we are good to click on this download tab. And our state file has been downloaded. If you see here, what we have done, we have used Terraform Cloud, and this Terraform Cloud is good to create the resources inside my Azure. And from Terraform Cloud, what we have done, we have only initiated Terraform plan and Terraform apply. And all these things are running inside my Terraform Cloud dedicated workspace. And where my state file is stored, it is stored inside my workspace. So this is a benefit of using version control workflow. Okay, so in the next video, we are going to discuss about the CLI driven workflow. Here we are going to discuss about the CLI driven workflow. So what we have discussed till now. In Terraform Cloud, we do have 2 options. The first option is VCS driven workflow and second one is CLI driven workflow. Okay, so in CLI driven workflow, we are going to run the Terraform commands from our local machine and our source code will present inside our source code will present inside our local machine only. So but in terms of the implementation, Terraform plan or Terraform apply, it would be done in Terraform Cloud and all the state files will be stored inside our dedicated workspace. So the first thing which we have to do is to create a dedicated workspace. The second thing which we have to do is the authentication part. The third thing which we have to do to update the provider for cloud configuration. In the cloud configuration, we are going to mention our organization name and our dedicated workspace name. And the fourth thing which we are going to do before running the command called Terraform init, we are going to run a command called Terraform login. And in this command, we are going to connect our local machine with Terraform Cloud. And to do this, we're going to use a PAT token. And once this task is done, the fifth step, it would be run our Terraform plan and Terraform apply. Okay, and eventually once the resource is created, the state file will be stored inside our dedicated workspace. Okay, so let's start our implementation part. So the first thing which I have to do is to create a project inside this organization. I'll click on new, then project. The project name it would be CLI driven hyphen workflow. Then I will click on create. I'm going to click on new to create the workspace. So it is asking where choose your workflow. My workflow for this implementation is CLI driven workflow. So it is asking for workspace name. I would mention CLI driven hyphen workflow hyphen workspace and the project it would be CLI driven hyphen workflow. Then I'm going to click on create. So our workspace has been created. The first thing which we have to do, we have to update the environment variables. So I'm going to click on add variable and the variable is environment variable. I'm going to copy this ARM client ID and the value is this one. We'll paste it here. Then I will click on add variable. The second thing which I'm going to do ARM client secret. Then I'm going to paste on value. Then on add variable. And finally, my tenant ID I'm going to copy. The value is this one. Then I will click on add variable. The last value is subscription ID. I'll click on add variable, then click on environment variable and then key. And then I will copy the value and then the add variable. So what we have done till now, we have created our workspace. We have updated the environment variable for authentication. The third thing which we have to do, we have to update our providers for the Terraform cloud configuration. Let me click on overview. If you see here, this is a code which we need to add in our provider configuration. I'll copy it and then I'm going to paste it inside. If you see, this is the same code which I have implemented in VCS driven workflow. The first thing, it is all about Terraform configuration, then our provider, the subscription ID, and it is going to create my virtual machine. And here we have created a variable for it. These are the variables and we are passing a value using demo.auto.tfvars file. So let me copy the path. So the first command I need to run, Terraform login. So it is asking, do you want to proceed? Only yes will be accepted. To confirm, yes, I want to proceed. It is asking me to create the token and by default the token will be valid for 30 days, but I want a token only for 1 hour. So I'm going to click on 1 hour. So this is a token which is created and it is valid for only 1 hour. So let me copy it. Then here I need to paste it. I paste the value, will click on enter. See, welcome to SCP Terraform. It is mentioned about the documentation and currently our local machine is connected to the Terraform cloud. So the first command I'm going to run, Terraform init. See, our Terraform init has been completed. So I'm going to run Terraform plan. See, 6 of the resources are going to be created and at the bottom there's one cost estimation. So it would be around $90 per month. I'm going to run Terraform apply. It is asking for confirmation. I'll type yes. See, our 6 resources has been created. Let me quickly check inside the portal. So we are having a resource group name called as demo-rg and inside this one we are having the 5 resources. If you see here, we are only able to see .terraform and .terraform log.scl file. Both these files are created when we initiated a command called terraform init. But we have implemented terraform apply also. And in this apply will create a state file. So are you able to see this state file in the local machine? The answer is no. And have we configured anything in terms of remote state management? No, we haven't mentioned anything, but we have implemented this cloud block. So let me quickly check inside the Terraform. This is my organization. And inside this organization, this CLI driven workflow. And inside this CLI driven workflow, if you see view all runs, so we have initiated 2 runs. The first one is it is for my plan only run, and the second one it is for my implementation. And both of them are successful. If I'm going to do any changes in my local machine, I would say from demo-rg to demo-rg1. And if I'm going to run again the Terraform plan, we have updated the resource group name. That's why it is saying 6 to add and 6 to destroy. So what is the end-to-end workflow of CLI driven workflow? Our source code will be present inside my local machine. We are going to run the Terraform commands. I would say TF commands from my local machine, but all the commands and the state file, our state file will be present inside my Terraform cloud. And if you noticed, while running the Terraform plan or Terraform apply, it is not running from my local machine. All these things are running inside my Terraform cloud. The first step it is showing connected to the remote stage. Let me show you in CLI. See, I have implemented Terraform plan. In Terraform plan, what is saying? Terraform plan in SCP Terraform output will stream here. Press Ctrl plus C will stop streaming the logs, but will not stop the plan running remotely. Preparing the remote plan to view this run in browser. This is the thing. Like I have to click on this one, and automatically my space will be opened. See, it is showing my 6 to create and 6 to destroy. And for the Terraform apply also, we have received the same thing. Running apply in SCP Terraform output will stream here. Press Ctrl-C will cancel the remote apply if it is still pending. If the apply is started, it will stop streaming the logs but will not stop the apply running remotely. Preparing the remote apply, and this is the block which has mentioned. So this is the Terraform version it has used. So whatever the things we are seeing on our terminal in local machine, it is only logs, and the end-to-end deployment is happening inside my dedicated workspace. Okay, so this is the benefit of using Terraform CLI. Okay, so with this we have completed this demo. So in the next video we are going to discuss about the Sentinel policy. This video we are going to discuss about the Terraform Sentinel. So overview of the Sentinel. Sentinel is a policy as code framework integrated with the HashiCorp enterprise products. It enables fine-grained logic-based policy decisions and can be extended to use information from external sources. So what is the exact meaning of it? As it is mentioned, enables fine-grained logic-based policy decision. Let's take example. We are creating a resource group in our Azure, but in my organization, it is compulsory to create a tax while creating any resource. Okay, so to achieve this one in Terraform, we do have the Sentinel concept. What Sentinel is? Sentinel is a logic based policy decision. So we are going to create a policy for it. If any resource we are going to create and tags are not present, it will give us an error. Okay, once we are going to run our Terraform plan, the Sentinel policy is going to be checked, is it up to the mark or not. If the Sentinel policy is saying okay, then we are good to apply it. If the Sentinel policy is saying like whatever the resources you do have created and tags are not present, at that time it is going to give us the error. If you see at the bottom, the overall result after a Terraform plan, it failed. Why? Because policy set one of them is failed. And the third thing, Sentinel policies are paid feature. Yeah. To use the Sentinel, we need to have the enterprise account. But in free account, we are good to create one Sentinel policy. High level structure. So the first thing which we are going to do, we are going to create a Sentinel policy. Okay. In the Sentinel policy, we are going to mention block virtual machine without tags. So if we are going to create any virtual machine without any tags, it is going to block it. It will give us an error. Then we are going to add this Sentinel policy to our policy, and then this policy will be connected to my policy set. So in policy sets, we can have n number of policy. The first one, it would be regarding the tags. The second policy, I would say it is regarding the specific virtual machine size we can only use. The third one, I would say only one data disk should be present in our virtual machine. If you're going to add two data disks, in this case, we are going to get the error. And finally, the policy set is going to be connected with my workspace. In the workspace, we are going to run our Terraform commands. Okay, if you want to have a detailed information regarding Sentinel policy creations and step, you're good to explore this HashiCorp documentation. So in the next video, I'm going to do a demo on this topic. So hello everyone, in this video, we are going to do a quick demo on Sentinel policy. So the first thing which we have to do, we have to write our Sentinel policy. And what is our requirement? I want all the resources should have tags. Okay. So once this Sentinel policy is written, we need to attach with our policy. Okay. And once this policy is created, we are good to attach this policy with policy sets. Okay. And finally, this policy set will be connected to my, and from the workspace, we are going to run our Terraform configuration. If the things are not matching to our policy, it will give us the error. If it is matching, then it will go ahead and apply the configuration. Okay, we do have some option in policy in terms of restriction, which we are going to discuss in our implementation steps. Okay, so let's firstly create the Sentinel policy. To create a Sentinel policy, we are good to explore the official documentation. Okay, and I have already created the Sentinel policy for this implementation. I'm going to click on settings. Then I'm going to click on create a new policy. The name of this one is demo hyphen policy. So in terms of the implementation of policy, we do have advisory, soft mandatory, and hard mandatory. If it is advisory, we are not going to get any kind of error while running the Terraform plan. Soft mandatory means we are going to get the error, but we are good to override it. And hard mandatory, it means like we are going to get the error and then we have to resolve it. Then we are good to move to the Terraform apply stage. Okay. Then I'm going to paste my policy code, and it is clearly mentioned like all the resources should have tags. If they do not have the tags, we are going to get the error. Then I'm going to click on create policy. So our policy has been created, and then I'm going to click on policy sets. Then I'm going to click on connect a new policy set. I'm going to select on individually managed policies. Then the name I'm going to mention as demo hyphen policy sets. I want to select as policy enforced on selected project and workspaces. So I'm going to select projects and I want to select VCS workflow demo project, and my workspace is VCS workflow demo project. Then with runtime I'm good, and then I'm going to click on next. So it is asking for my policies, and this is the policy which I do have created, demo hyphen policy, and inside this policy I'm having my Sentinel policy detail. Then I'm going to click on connect to policy sets. So it has been implemented on my VCS workflow demo project. So let me quickly show you inside my source code. If you see here, I haven't created any tags for my resource group name, for my virtual machine, or for my virtual network configuration. So let me run and check whether it is going to give me any error or not. So I'm going to click on plus new run. I will say plan and apply. We'll click on start. So plan is in queue stage. See, after the Terraform plan, we are getting an error. The error is Sentinel policies errored a few seconds ago. It means like we are getting this error because in our source code we do not have any tag. So what we have to do, if I'm going to update my source code with a tag, then this Sentinel policy will be good. So this is the basic implementation of Sentinel policy.